It goes green.
Test, can you hear me? Hello. It's not working. Test, test. Test, test. Test, test. You're talking to her like this.
It's the distance, I think.
I suppose I could do this. I think I might prefer that.
Is there a volume? Good evening, everyone, and thank you for joining us for the School of Architecture Annual Theis Award lecture. I will begin with our university's land acknowledgement statement, say a few words about Michael Theis, that this lecture series is in his honor, and the Theis lecture. And finally, I'll introduce our special speaker for this evening's lecture. We acknowledge that we are on the lands of Peoria, Kaskaskia, Piankashaw, Wea, Miami, Mascoutin, Odawa, Sauk, Meskwaki, Kickapoo, Potawatomi, Ojibwe, and Chickasaw nations. These lands were the ancestral territory of these native nations prior to their forced removal. These lands continue to carry their stories, their struggles for survival, and the preservation of their identities. As a land-grant institution, the University of Illinois bears responsibility to acknowledge the peoples of these lands, as well as the histories and of disposition that enabled this institution's growth over the past 150 years. This acknowledgement, along with the commitment to centering Native peoples, is only the beginning as we work towards a more just and equitable future. This evening's lecture is supported by the Michael J. Theis Memorial Fund. This fund was created to honor Mr. Theis and to support in his memory his combined interest of engineering and architecture. Mr. Theis received his education here at the University of Illinois School of Architecture with a Bachelor of Architecture in 1970 and a Master of Science in Architectural Engineering in 1971. His career as an engineer spanned over 2 decades, many of which he spent in New York. His project work included design of tall buildings, as well as other distinctive buildings, as well as restorations and renovations. Michael J. Theis Memorial Fund is used to support events at the school to encourage and promote the study of structures in architecture while facilitating interactions between students and practicing architects and structural engineers. We are grateful to Michael's wife, the late Cindy Theis, as well as Mr. Theis's good friend, Ron Johnson, for their support of the Michael J. Theis Memorial Fund, which makes this evening's lecture possible. I understand that Ron Johnson is joining us via Zoom. Thank you, Ron. We miss you here in Champaign. Cindy and Ron used to attend these events every year. Unfortunately, Cindy is no longer with us, and Ron was unable to join us this evening in person. And now a brief introduction of our speaker. Michelle Ryland is a dual licensed structural engineer and architect with Klein & Hoffman in Chicago, specializing in the adaptive reuse, restoration, and repair of vintage buildings across Chicagoland. She holds a Bachelor's of Science in Architectural Studies and a Master of Architecture with the Structures option from the Illinois School of Architecture. Michelle is very active in numerous professional organizations and is currently a member of the Board of Directors of the Structural Engineers Association of Illinois and the National Council of Structural Engineers Association. Please give a warm welcome to our special speaker, Michelle Ryland.
Thank you, Abbas, very much. Can you hear me in the back? Good? Okay. Thank you, everyone, for coming this evening. I'm excited to share Shed Aquarium's Experience Evolution Phase 2 project with you. And I do recognize that there's a big basketball game tonight, so I appreciate you spending some time with me first. All right. Now, I don't have to go through the slide because Abbas just did. So, again, I'm Michelle, and always happy to return to campus for an opportunity to talk with current students. On to the project. So Let me take you back to a time in 1927 Chicago, the roaring 20s. People were living in luxury, unaware of the financial cliff that was looming only a couple years away. During this time, well-known architects Graham Anderson, Probst, and White were retained to design a Beaux-Arts-style aquarium building for the city of Chicago. It was to be a world-class aquarium, a museum of aquatic life exclusively for educational and scientific purposes. It was funded by then president of Marshall Field and Company, John G. Shedd, with a gift of just $2 million, and used a similar architectural style to the nearby Field Museum named for Marshall Field. Unfortunately, John Shedd died in 1926 before construction started, but the not-for-profit Shedd Aquarium Society, which still exists today, forged ahead and broke ground in November 1927. Construction took 2 years and another $1 million, and the first exhibits opened to the public on May 30th, 1930. Supposedly, Shedd's widow cut the ribbon at the official opening ceremony. And 3 years later, in 1933, Shedd was part of the Century of Progress World's Fair, located at the north end of the fairgrounds. The Shedd is a neoclassical temple of white marble and terracotta that was created to educate and celebrate aquatic life. Marine-themed motifs are incorporated in the design and decoration at every opportunity, all over the building's exterior and interior. Every time I go there, I see something that I haven't noticed before. The amount of detail in this building is incredible. Next time you visit the aquarium, look for these details. You will be amazed. They're everywhere. Can we turn this light down? No, that's okay. All good, thank you. All right. All right, so the original building is octagonal, but it technically has 16 sides as the octagon is intersected with a cross. The building is organized on a rectilinear column grid, and one of my favorite pieces of trivia regarding this is that instead of identifying locations with column grids, like you see normally, they numbered their columns. 75, 76, 77, 78, 79, column 113, and column 114. Shedd still uses this numbering system today. If you go into their building in the back of house spaces, you will see the columns with their number painted directly on them. Later, we will talk about columns 227, 228, and 251A, and column 88. All right, the building is supported by a hybrid structural system. Concrete framing at the lower levels transitions to riveted steel framing encased in concrete fireproofing at the main level and roof, with a 5-wide load-bearing unreinforced masonry wall forming the building's perimeter and lateral system. The structure rests on composite timber and concrete piles, and at the roof level, these are skylights that are over the original exhibits, and then this is a 10-foot tall parapet wall, which fortunately has an embedded steel frame that is braced back to the roof. Much of the lower level of the basement was originally designed as reservoirs to store and filter the water. The original basins were located in these areas, and I know you can't read it, but they say live load of 500 pounds a square foot. That's in the basement. Interestingly, in 1930, Shedd's saltwater exhibits were stocked with seawater, not by adding salt to Lake Michigan water, but by transporting nearly 1 million gallons of water by train from Key West to Chicago. Now, Shedd makes their own saltwater on site. The ground floor, or the mezzanine, was basically a ceiling of these reservoirs in the basement. So it was the lid. It 5-inch thick concrete slab, 33 KSI rebar. It had a live load capacity of 10 pounds a square foot. Now, if you think about current code, there is a live load of 10 pounds a square foot. It's uninhabitable attic spaces with no storage. This limited slab capacity has created many challenges for shed over the past 5+ decades specifically, and we'll talk about some of them in more detail later. Some locations have a live load of 50 pounds a square foot. These were drive aisles for the trucks that had the seawater to come dump them into the basins below. And as mentioned, above the ground floor, you transition to steel framing, and then here's your main level, and you can see how they delineated these public spaces into each a gallery, and then behind the scenes spaces in the corners. They all have the same live load of 100 pounds a square foot. All right, beginning around the 1970s, multiple renovations and additions have altered the building structure, expanding the useful floor space within the original footprint and increasing the aquarium's capacity to house animals. Klein and Hoffman has been involved in most of these projects since the 1990s. Oh, whoops, wrong button. There we go. This button. So the Oceanarium was the first major addition. It was built in the late 80s and opened to the public in 1991. Wild Reef is 2 stories below the South Terrace. It was constructed in the early 2000s. The accessible entrance was added in the mid-2000s, and then here's this sculpture. It's called Man with Fish. Amazon Rising was done in the mid-2000s. It completely redid the entire South Gallery. And then in the mid-2010s, the Rotunda skylight was completely replaced. It improved its function, and it also restored original design elements that were lost during the prior skylight replacement in the 1960s. Solar panels were added to the roof of the Oceanarium. It was the first such installation in the city of Chicago. And then the Stingray Touch was added to the top of the South Terrace. This is a seasonal exhibit, May through October, I think. And then a myriad of other exhibit enhancements and behind the scenes concrete repair, waterproofing, masonry repairs, way too many to list, that we've been involved with in our 30+ year relationship with the aquarium. And finally, I'll mention that in 1987, Shed was placed on the National Register of Historic Places. All right, so as you can see, Shed has been very proactive in adapting its building since its opening almost 100 years ago. And ahead of its centennial year in 2030, Shed Aquarium unveiled a strategic plan called the Centennial Commitment to accelerate its mission and prepare the iconic institution for the next 100 years of service. The plan includes an ambitious experience evolution that will restore the aquarium's historic architecture, modernize the experience for guests, and upgrade life support technology, and create more expansive, realistic habitats for animals. The experience evolution process began in 2018 with an extensive research and master planning process aimed at redefining the visitor experience while maintaining a deep commitment to animal care. A multidisciplinary team, including experts in human factors design, exhibit design, and architecture, created a visitor-focused, actionable plan. As the project progressed, the design team expanded to include 18 specialty consultants, necessitating careful collaboration at every stage. Here are some of the primary ones. Obviously, Shed is the client. Jones Lang LaSalle is the owner's rep. Valerio DeWalt Train is the architect of record. Brown and Moman and Pepper Construction are a joint venture GC. TJP is the life support systems engineer. That is everything that goes into the animal habitats, so the filtration systems and things like that. MSA is your mechanical engineer, and Think is the exhibit designer. All right, so the experience evolution is split into 4 phases. or really 5 if you want to count phase 0, which was an enabling phase. So what that means is before construction began, the aquarium temporarily relocated animals from their public habitats to environments behind the scenes where they could continue to receive quality care while their new habitats were constructed. Phase 1 was also behind the scenes. It involved closing down the underwater beauty special exhibit and relocating Shed's hospital and lab space so that important animal care procedures could continue without interruption. We'll dive into phase 2 in a minute. The project is currently in phase 3, which completely reimagines the entire north section of the building. And here are a couple of renderings that have been released to show what's to come in phase 3, which I believe will open in 2026. Phase 4 is probably the smallest phase in terms of cost and scope, and it primarily involves non-structural exhibit enhancements to the original East galleries. And it also will be when the entire Kovler Hall is reopened. All right. Throughout construction, Shed has remained open. This is a logistical feat requiring precise coordination to maintain animal support systems, visitor pathways, and operational back-of-house spaces. Every phase prioritizes the visitor access and uninterrupted experiences. Now, back to phase 2, the topic of this presentation. Phase 2 completely reworked the entry sequence with a new arrival hall, fixed major circulation problems, and reimagined several exhibits, like the center exhibit and the Arapaima habitat in the South Gallery. All right, you may have noticed that I have not mentioned this little piece down in the southwest corner. This is the new ticketing pavilion, entrance pavilion, and then these trellis features that surround the man with fish sculpture. Everything that is outside of the historic building footprint was done by a separate engineer of record. It's kind of unique to this project, but in this case, Thornton Tomasetti designed the entry, ticketing, and trellises. And maybe someday you can hear Thornton Tomasetti talk about this project because it was challenging. Even though it's small compared to everything else going on in the historic building, there was so many challenges. They had to redesign foundations about 3 times due to undocumented obstructions below ground, but that's for another time. Maybe that'll be a tease. You can get another speaker of us. But I can give you a little bit of background information on that entry. So when Shed was first constructed, the main entrance was through these grand stairs on the west. However, once the accessible entrance, which is here on the southwest corner, was added in the early 2000s, that became the primary point of entry. And then during the master planning in 2018, research did confirm that 85% of visitors do approach Shed from the south, prompting the creation of a new plaza for a seamless, accessible arrival experience. The landscape plaza and lightweight trellis unify the outdoor space while preserving sightlines to the historic 1930s building and incorporating wave-like motifs in the trellis that you can see there, complementing all the other aquatic motifs found throughout the building. The pavilion roofs are delicately positioned to maintain views with materials selected to complement the white Georgia marble of the original structure. All right. Now, once inside the building, the handcrafted plaster wave wall right here extends that plaza's trellis motif, creating an immersive aquatic aesthetic in the beautiful interplay of light and form in a brand new 2-story arrival hall. This area was previously pretty dark and somewhat uninviting, and a stated goal of the experience evolution was to establish an open, welcoming experience. So the team said, let there be light, and we removed 5 structural bays to allow the main level windows to bring daylight into the new entry hall. So let's talk about how we achieved this. So removing floors is always good for your gravity loads. It takes load off your columns, it takes load off your foundations, However, it means that you now have columns with double the unbraced length. So we had to check all those, but fortunately they were robust enough that we did not need to reinforce any of them. As I've stated before, the perimeter masonry wall is load-bearing. You can see sort of up here how the roof framing does frame right into the wall. And it's also the building's lateral system. And it has a 10-foot parapet wall. I mentioned that earlier. So removing this floor down here, though, means that this wall is now 32 feet tall, unbraced for out-of-plane wind load. And even though it's 5 widths and it has pilasters every 16 feet, it's not going to work for that kind of span. So we had to design a permanent strong back system to brace the wall. And so if you'll notice, so basically we installed columns. I gotta get this button right, boss. Back, there we go. So we basically installed columns roughly adjacent to where the pilasters were, and then the whaler is turned sideways so that the strong axis is oriented parallel to the load, the applied load. We also had to mechanically attach the whaler to the wall for pressure and suction. Some modifications were required at the roof level due to the original drawings not being completely detailed, and so once the demo of the ceiling happened, we could actually see the roof structure. We knew that some of our original details weren't going to work. So these ones up here were not our original design, but you can see that the actual installation matches pretty well. That's always nice to see when you see your 2D drawing in 3D real life. And then here are just some photos of the process. So again, the strong back system had to be in place before the floor could come out. So what they did is they demoed small portions of the slab to install the columns. They had to demo part of the pilasters so that the whaler could sit flush against the wall for the whole length. Once they got the columns installed, they did their splice, and then here's the horizontal whaler getting ready to be installed. Once everything was in there, you could see the bolts connected there, then they could take out the floor. Yeah, there's the strong back system in orange. It's kind of hard, there's so much going on in here, it's kind of hard to see without that highlight. All right, so from this view, if you turn around, you will see this, which is affectionately known as the golden elevator by the design team. See, there's gold on the walls, and we took group selfies there every week in phase 2. Why? I don't know. We just did. So the elevator was added in the early 2000s during the accessible entrance project. However, it was really the only way to come into the building and then get up to the gallery levels up here. There was another stair that was kind of like back around a corner, but really you came in the doors and then you waited in line to take the elevator. So now, though, there's escalators and stairs, so a variety of options to get you up to the grand hall and galleries. Now, before I get into the escalators and the stairs, I want to talk about this column. Now, it's a little hard to tell in this image, but the enclosure around this column is substantially wider than this one. Now, why, you ask? Well, I'll tell you. This is column 251A up at the top, right here in plan, and you can see that it is off-center and skewed from column 251 directly below it. So here's 251, here's 251A. I don't really know why they couldn't have aligned it, but my guess is putting 251A at this location simplified connections up at the roof level, and they probably never thought that this girder was going to want to be removed. So we were supposed to remove this girder because it's right in the middle of our double height space, but we couldn't remove all of it. And then this is not a moment connection, so we had to install this kicker to resolve that off-center load. So once all that was installed, then they could cut that girder, and you'll see it is gone from there. All right, so now back to the escalators. So we had to add framing at the top of the escalator to support the operational load of the truss, the escalator truss, and also to support the edge of the original floor slab that we had cut back. So if you'll notice in this detail, so here's our plan, and here's the section. So if you notice, we have a tube and a wide flange shape. That was not the original intended design. Originally, this tube was located where it needed to be for the escalator, and then the floor slab was supposed to be cut right on the other side, and then this little stiffened angle down here was supposed to support the floor joists beyond it. However, the demo contractor got a little ambitious and demoed the slab back before he had coordinated the exact location with the escalator manufacturer. So that meant when it was all said and done, the opening was 4 inches too big. So the simplest solution at that point was to specify a separate member, in this case our W12, which is right here, to support the edge of these joists that had been cut. And then that stiffened angle on the side of the tube is now just supporting that 4 inches of new concrete that we had to infill. So stuff like this happens, right? So things are not perfectly coordinated. At the end of the day, it was the general contractor that should have pointed out to the demo contractor where he should have cut, but it happened. It's 4 inches. You got to work together as a team to come up with the best solution for the entire project. So that was one small little change we had to make there. Then at the bottom of the escalator, we had a pit to house the escalator machinery. And you can see this, so the mechanism that operates the escalator is down here. It's a little hard to tell from this photo, but we had to make this as small as possible, as shallow as possible, because this space below here is an LSS room, life support systems room. So the equipment and filters that were in this space down here absolutely could not go offline. They needed access to them. And the door to get in that room is right to the north of our escalator pit here. So we squeezed as much space as we could so that there's still enough room to come in these doors and then get to the rest of the filters and stuff that are in the space. And in our detail, you'll see that we actually tucked the slab up into our framing. So normally you have your framing and your slab sits on top of it. Well, you can also do it this way and save yourself 12 inches of clearance. So, you still can't walk under here. That's not enough height, but it's sufficient for shed to still use the space for storage and things like that. So that was a must on their end. And here are just a few photos of the installation. So an escalator this is called the truss. The two sides are trusses. They come to the field like that. It's installed, and then each of the stair treads is installed one by one once the truss is in place. All right, now on to the stairs. The stairs were pretty straightforward. But they did impose a large point load at the base and the center. From the center landing post did impose a load on our ground level structure. And remember, our ground level structure has no capacity, more or less. So we needed to reinforce, but we didn't have access from below, so we designed an option to reinforce from above. We basically designed a steel beam that was stiff enough to span column to column, and then with stiffeners where the supports from the stairs would land. So here it is in the drawings, here it is mostly installed, and then before they installed this 8x10, I asked if I could pick it up to prove that I could pick it up. So I did. All right, the last column this is our second column problem. At the very top of the stairs was column 228. So 25 years ago, during the Accessible Entry Project, column 228 was moved from this location, which is here, about 5 feet away, to this location here. I don't really understand why it was moved. There was obviously some reason that they needed to move it. And what they did is they literally cut it here, and they reused it, the same column 228 relocated. So the same column was reinstalled 5 feet away. Well, now it's at the top of our stairs, so we moved it back. So the moral of that story is that not every renovation has to be forever. And this is a brand new column. We decided that one column should only have to move once in their life, and so we put a new one there. And then above the escalator and the stairs is a one-of-a-kind art installation by a local Chicago artist called Once and Forever Lake Michigan. It is supported by, this looks really dense right here. It's really very light. I think because this photo is dark, you can see it more, but this is a bunch of basically fishing line that hangs, I think, 1,600 fish. It's all supported off of the original roof structure, and so our role for this art installation was to analyze the roof structure and provide the artist, an allowable design load for their sculpture. And then we'll close out this section by comparing the rendering on the left with the completed construction photo on the right. Does anyone notice anything? What's that? Yes, the stairs. The stairs are switched. The stairs were supposed to be over here, and now they're on the east side. So that is because you'll notice that these escalators are wider than normal in the rendering. That was the intent. However, there was a discrepancy between the drawings and the specifications. I don't remember which one was correct, but the general contractor, I think the drawings had the wider escalator and the specifications had the standard width escalator. And that's what the general contractor based their price off of, was the standard width escalator. And by the time anyone realized what had happened and that there was that discrepancy, the ship had already sailed. Apparently there's quite a cost differential between a standard width escalator and a wider escalator, and there just wasn't, we were too far along in the process to kind of shift things around to make the budget work so that we could do the wider escalators. So we decided to stay with the standard width escalators, but then, if the stairs are still over here, then you've got this empty blank space. This looks kind of weird there. So we agreed that moving the stairs to the east side of the escalators was the best solution. All right, so most guests, so the arrival hall is over here, and there's those stairs we were just talking about. So most guests will go up those escalators or up those stairs to the grand hallway and those galleries. Or you could take this new hallway to go to the Wild Reef elevators and go down and see the sharks, or you could keep going up this ramped hallway to the oceanarium to see the penguins and the belugas and the Pacific white-sided dolphins, otters. I'm probably missing some more, but previously the access to get to the oceanarium or the wild reef was you had to go up the stairs, then you had to go around the rotunda, and then find the elevators to go up, down 2 floors. Or then you had to go find the 2 stairs that go down to the oceanarium. It was very convoluted. And so this streamlined circulation pathway was a huge point of, or a huge goal of phase 2 in specifically. And what this space was previously was, I think this was a lunchroom. There's some offices on the sides here. It was just a really weird, not well utilized space. So that relatively simple renovation, we're just adding a ramp, right? Not that big of a deal. Well, remember when I said that the ground floor had a capacity of 10 pounds a square foot, and shed, it created problems for shed for like 50 years. So basically, what each of these hatches represent is a different renovation, a different repair, a different structural system. For example, this space right here used to be completely open to the basement below. And so this is like a composite steel framing that was infilled in the 1970s. All of these crisscrossing steel beams that you see over here, those were added to cut down the span of these slabs that only have a 10 pounds a square foot capacity. This here is a bonded overlay, which increases the capacity to, I think, 50 pounds a square foot, maybe 100, I don't remember. But basically, shed had all this documented, which was super helpful, but it was a lot of documents we had to sort through to understand exactly what was going on to create our ramp down here. So the original, anywhere there's not a hatch is the original structure, and then there was 7 different iterations that we had to look through for our analysis. So here's that ramp that I was talking about. So obviously we had a big elevation difference. We're at roughly 35 feet here, and we're going to 39.6 over here. So to reduce the amount of load that we're adding, we opted for a thin concrete slab on metal deck, supported on metal stud knee walls. So that was about the lightest structure we could do. And fortunately, all those prior repairs and reinforcements that shed had already done made it so the slabs worked. We didn't need to reinforce the slabs. However, several of the beams along the perimeters were failing either in, some were failing in flexure, and all of them were failing in shear. So we had to reinforce them. So this was our original detail. It was basically an underside and a topside reinforcement option. We added longitudinal bars here to increase the capacity in our tension zone, and then this bar here gives us the missing shear capacity that we didn't have. However, during construction, there was 1 or 2 locations where we absolutely could not do anything from below due to LSS piping that could not be relocated. So fortunately, in those cases, the beam wasn't failing in flexure, it was just failing in shear. So we were able to just install the shear reinforcement from the top side. And here's a few photos of the construction. So here's those knee walls being started, metal deck is added, and then the concrete is added after that. All right, now moving back to the arrival hall. So here's that golden elevator, escalators and stairs. Behind it is the new gift shop. And again, this area was originally a basin cap, capacity of 10 pounds a square foot. A gift shop needs to have 100 pounds a square feet loading. So this area in the 70s became the education wing with the classroom loading of 40 pounds a square foot. So I mentioned shed has been they have excellent documentation of any building I've ever worked on. They have by far have the best record keeping. However, this is one set that I really needs some work. We have 2 sheets for this education wing. They all look like this. you can't read half of the general notes. We can see that they did a raised floor system, which is lightweight concrete on CMU blocks for these knee walls at 4 foot on center. There's nothing in here that indicates that the slabs that this system is sitting on was reinforced. So it's clear that they were trying to spread the load, like I don't know if they were thinking, okay, we're gonna make it linear and now it'll work versus a uniform load. But you're adding dead load. You're also adding live load because you're going from 10 pounds to 40 pounds of live load. And I don't know. This is one big question mark still. We don't know what is going on here. But anyway, that's a mystery that will never be solved. So now it's no longer the education wing. The classrooms are moving up to the main floor during the phase 3 of the project. Now it's the gift shop. So we've got 10 pounds capacity. We need to get to 100. How can we do that? So there's a couple options we looked at. There's something called a bonded overlay, which I won't get into all the technical things of what that is, but it's very hard to achieve. You have to do very specific surface preparation to the base slab that you're pouring your new slab on top of. And you also have to test that bond. And lots of times it fails. So what's your backup plan if it fails? Furthermore, you're limited to the amount of capacity increase that you can achieve. I don't think a 10-fold increase would have been allowed by code. We also looked at reinforcing by adding steel framing below the slabs. This would allow us to cut down our span, but we didn't have access in all areas, so that didn't work either. So what we ended up doing is we designed a new 6-inch cast-in-place slab using the slab that was there as the formwork. However, that needed to be shored for the wet weight of the concrete. So, and this is also the area where we're transitioning from concrete framing to steel framing. So how do you develop your moment at your negative regions at your columns? Well, you install these really robust steel angles, and then you weld your rebar to them. And in some cases, this is kind of hard to see in this photo, but this base plate was like 2 inches thick. So we were fine with welding directly to the base plate and we could omit those angles at a couple locations. So a couple construction photos. So here's what they've removed: the concrete fireproofing, the concrete encasement around all these steel columns. They're starting to install the steel angles. Here's the staging for all the rebar. Is rebar installed? Obviously, you can see visually where you have darker rebar is where you have your higher reinforcement for your tension zones. And then this is the completed slab. It looks basically just like this one, only you can't see the very base of that. All right, so that was the gift shop slab. Now, the most complicated part with the gift shop slab was the entrance, which, actually, I'm going to go back a few to show you. So here's the architectural plan. So this is their entrance to the gift shop. And column 227 is located like right there. So basically, so I think this is our third column. So 227, oh golly. So here's the historic west stair going up from the ground level up to the galleries. That's the stair opening right here. The corner of it is column 227. Column 227 goes down to the ground floor and lands right there. There's no column below it, so it's on a transfer girder. Transfer girder, 3 transfer girders to support column 227. The transfer girders are 36-inch deep, and for reasons that nobody knows, 18 inches of that transfer girder are above the slab, and the other 18 inches are below the slab. I feel like they probably did that because they needed the space below, so they didn't want a 36-inch beam going into the basement level. And the ground floor, remember, was unoccupiable, basically. So an 18-inch tall curb wasn't really a big deal 100 years ago. Well, now it was a big deal. So we explored, so here's just some demo. So we couldn't see these transfer girders because Shed years ago had installed a raised floor system, and this was like an IT room. So it wasn't until they demoed that we could finally see, yep, those transfer girders are exactly like they are shown in the drawings. So we looked at getting rid of the column. Was there a way to completely reframe the main floor that it was supporting so that we didn't need a column at this location? But that would have, you would have to cut out so much of the main floor to put back an efficient system. So that was nixed. Then we looked at, well, could we add a column below here? Below here is a staff lunchroom. Could we add a new column below here with a smaller foundation so that this load just goes straight there, and then we don't need any of these transfer girders? Well, anytime you say the word foundation, the costs quickly escalate. So that wasn't an option either. So, oh, and then before I go into our solution, so these are the beams from below, and then notice this data tray and these conduits. These two items serve Shed's command center, which, as I understand it, it monitors basically every system, every habitat, every filter, how much solar energy is being pulled in from the panels. All of that goes into the command system. So these guys were not going anywhere. So what our solution was, okay, well, we need to get rid of this part above the slab, so let's enlarge the beam below. So we made it deeper, we made it wider. We have number nine bars with a 180-degree hook. And then we tied it all in. We have these stirrups that had to be drilled through the original slab and then bent into the new slab there, which I will show you in pictures what that looks like. So again, staging for our rebar, and that's installed. A number 9 with a 180-degree hook is a very big deal. Try to avoid it if you can. And then here's those stirrups that came up through the slab. So once the rebar below was installed and the concrete was poured and it was cured, then they bent these bars into the slab like so. They demoed the transfer beams, and then here they did do a bonded overlay reinforcement. This was just in one bay, so we were more comfortable doing that here versus all the gift shop solution where that was like 16 bays. So, and this is what it looks like below. So it's much deeper than it was, and it's a little hard to see in this photo, but those conduit and that data tray was basically cast right into the concrete. It's not going anywhere. All right, so let's move on to some exhibit enhancements, shall we? Is it really 6:51? Wow. All right, I'll go faster. So the original Rotunda exhibit was called the Tropical Pool, but it was affectionately known as the Swamp. And it included a recessed area in the center for alligators and other swamp animals. And it wasn't until 1971 that the center exhibit was extensively changed into what most of us remember, the Caribbean Reef. So the new transformational Wonder of Water exhibit had to fit entirely within that same footprint as the original swamp and Caribbean Reef. And the structural design of this exhibit requires a presentation of its own, and I'll do my best to provide a very high-level overview of the complexities and challenges. And for the sake of time, I will probably skip through some of it, actually. I'll just have to come back and tell you more about it. But basically, the Wonder of Water was a juxtaposition of a saltwater habitat and a freshwater habitat. So it needed, obviously, 2 different exhibits, which meant 2 different life support systems, 2 different plumbing, sets of plumbing lines. They had to be completely separate. 2 different lighting systems, because you're inside the building, and the saltwater tank has live coral, which needs very specific lighting for the coral to grow. So let's see. So obviously this is, hold on. So this, with this very unique organic shape, we made it out of concrete, except for, gosh darn it, sorry. Except for these 4 columns right there. Those are steel tubes filled with concrete. So we only had, the exhibit designer was very specific that he basically wanted a very thin vertical support there, and he gave us 8 inches square to work with. So if you're talking about an 8-inch square footprint in concrete, you've got your concrete cover, you've got your ties and your vertical bars, you basically have nothing left in the center. So really, concrete filled steel tube was the only option. Right, these next slides have quite a bit of commentary, so I'm just gonna skip it all for the sake of time, but we'll go through the model. Basically, there's a lot of stuff that had to fit on the service deck. We needed a continuous walkway around the entire thing, but we couldn't have any vertical supports beyond the service deck. Then you got your tanks. There we go. So there's one of our concrete-filled steel columns. Fortunately, we got an actual wall on this side, but then this is a beam that's it's supported here and it's supported here. So it's a curved beam that's cantilevering. Then here is the base below the tank slab. On the underside, now we're in that original pit. That's where all your life support stuff has to go. It's very congested under there. We don't have time to go through the analysis. There's a lot of unique stuff to talk about. And again, this presentation is an hour all in itself. But we checked the original structure. Again, this is historic steel, 18 KSI allowable stress, but very over-designed for what we needed. So we didn't need to reinforce the plate girders or any of the columns. So in the other image, you saw all of the life support pipes and stuff that go through here. Well, you need access to those. What if there's a leak or you need to repair them? So we accommodated 2 access openings in each of the tank walls so that a person could get in there and do future repairs if needed. Now, the curves on this, there are, I think, 5, yes. So the design, the analysis really wasn't that complicated. The design, you've got your load, you can figure out what you need. It's the detailing that was so complicated because you can see with all of these curves, how are you gonna fit the rebar in there? So rebar can only be fabricated to one curve. And then it can lap with another one that's at a different curve. So there were so many different curves. This is actually a very simplified view from what it started out as, but there were so many curves and so many lap splices. Plus we were using epoxy bar, so you increase your lap splices by 30%. That there was we were dealing with major rebar congestion issues. So fortunately, the exhibit designer was willing to work with us and simplify things a little bit. And then, so you'll see the three window areas, that's where we had three pieces of acrylic. And then our concrete filled steel tube, we added plates on the acrylic side so that the acrylic could bear right up against that. And then back to the service deck. So there's that ring beam that I talked about in yellow. So it's supported here at the wall, and it's supported here. It's curved, and it's cantilevered out here. Plus, it's supporting this slab, which is only on one side. So now you've got torsion on the beam. Then around the whole perimeter of this thing is this light railing that is serving as a guardrail. It also has lights on it. So it's now an extra linear load at the edge of a cantilever, further exacerbating our torsional issues. Anyway, we looked at each one of these things separately and resolved them, made sure our reinforcing was accounted for it. But again, like I said, in and of, we could present on that just by itself. So now let's look at some photos of the demolition and construction. So here is the original, not the original, this is the, this is the Caribbean Reef. So it was basically a big bowl that sat in that original pit. So here it's being demoed, and now you're seeing that pit being exposed, and then the openings that go all the way down to the basement that you can see right there, those are covered with a work platform, so you can't see them in that image. So here's some, again, the rebar in here was so complicated. You can see here, this is what I'm talking about when I say the rebar can only have one curve in it. So it's fabricated to the radius that is most applicable, and then in the field, the guys basically force it back into the second curve. We had to remove the concrete encasement around this existing steel column just so we could get our clearances. And then we had, it's really hard to see, but we added Nelson studs to the beams down here just to tie everything together. And then here, this pipe back here is another life support system pipe that couldn't be relocated, couldn't go offline. And right in the middle of where we wanted to put our new wall was a flange. It basically turns the thing on or off, and right, like literally right there. So we had to create a box out for that flange so they could still operate it. Here are those walls, the tank walls, and you can see here's the box outs for those access openings into the interstitial space, and then here are those openings that go all the way down to the basement level. And then here's the top of the walls. That curb has needed to be poured. Someday I'll get this right. Sorry, guys. So concrete is poured up to a certain level, and then we've got our slab between the exhibits to be poured. That's this one, and then the upper slab at the actual tank level is then poured with the rebate and all of this. All right, this one. So this one really shows the rebar congestion issues that we were dealing with. So in this photo here, oh my gosh. In this photo here, this is just part of the bottom mat of reinforcing. So you've got your bars that are coming out from the perimeter walls, and then this thing is 30 inches in diameter. It's called a sump, and it's going into this hole. And then there's a second one that's going to be cut right here. And whenever you displace rebar for a penetration, you have to put the same amount on either side of it so that the load will transfer around it. So, and then you got to do your top mat on just a few inches away. So this is the final, this is what it looks like when it's all said and done. And we, believe it or not, this is actually less congested than what it could have been if the contractor had just straight followed our drawings and typical details. They had concerns, they brought them to us. We worked through them in the field to make sure that the bars that we needed could be installed, but that there was still room for the concrete. Because honestly, like this is, in some cases it was so congested, there wasn't room for like their vibrator to get down in there. And then here is just a picture of the space below once the slab was done. And this is up at the service deck. So here is that ring beam, that cantilevered ring beam that's going from a wall to the column over here. Here's another penetration in the slab, so you can see what I mean about the additional rebar around a slab penetration. And then when it was all said and done and the shoring was removed, this is the prettiest concrete I've ever seen. So I don't know about you guys, but I would be okay if they had left it like this, but unfortunately this doesn't hold water very well and people want to see fish, so they had to cover it all up. But doesn't it look cool? I think it looks cool. And then here is them bringing the acrylic into the building. So we actually did think about the maximum size of acrylic pieces that we could actually physically get into the building. And you could see we basically were maxed out in height. Then because the openings have rebates on the sill, on the jamb, and on the head, the only way to install the acrylic was to lift it up over the service deck and then drop it into place. And you can see right there, it's touching the beam, the ring beam, and there's only a couple inches to spare over here. So this was very tight, but the contractor was fantastic and everything was installed, no problem. And then lastly, just a few quick mentions that I skipped over a lot of the structural stuff, honestly, but there was so many other things with this tank in particular. I mentioned lighting. So again, this is the saltwater habitat and the freshwater habitat. They each have their own lighting requirements. You can't just put lights on the edge. You need to get them out over the middle of the tank for maximum effectiveness. So these swing arm, but then how do you change them? Like if a bulb goes out, how do you get it back out there? You could get on like a little raft and go change it. That's what they've done before, but that's really not safe. And so these are swing arms, so you can rotate them back off to the service deck when you need to do maintenance to those lights. We went back and forth on these lights for so long. Like, I have to say, this was probably the most complicated part of the whole project, believe it or not. And then underneath the service deck, right, so this is an occupied space. This is where all the visitors go between the tanks. This had to be sprinklered. So we've got sprinkler lines in here. You got electrical, it needed to be conditioned, so you've got your ductwork going under there, and they didn't have a whole lot of space to work with either. So a ton of disciplines the coordination on this tank, we were meeting for months before we finished design, even during construction, still trying to make sure we had the best, most efficient solution. So then closing this out, again, a comparison of the rendering and the final completed project. And I think the team did a pretty good job. All right, this is the last section. So the Arapaima exhibit. This is another great example of repurposing the existing structure from a previous era of renovation. So Amazon Rising, as I mentioned before, was constructed in the early 2000s, and it utilized 36 KSI steel. So this was kind of right at the transition between using 36 and using 50 KSI steel standard. And this is an Arapaima. He is a prehistoric fish that can grow up to 10 feet long. And so this was his original habitat. It was like this L-shaped thing. And for a long time, it was fine, but he keeps growing and growing, and I think they have more than one. So he needed more space. So what we did, so this L was his original tank. So we took this part. I don't know what was here, but we took it. And then we are expanding it out into this tiled space. So now this is all his swim area. So again, so that was originally public space, concrete joists, 100 PSF, but 100 PSF is about 18 inches of water. We needed 5 feet of water, 5'4", I think. And so really the best way to do that was to remove what was there and go back with a new, more robust system. So we demolished the concrete joists and we went back with a composite steel frame system. So this is this, and here's with the rebar, and you can kind of see this right here, that is the rebate that the acrylic will sit in. Now, to our last column problem of the evening. So the complication with expanding the Arapaima exhibit out into the public space is that this column is column 88. Column 88 is now going to be in the middle of the tank. Before this white area was the original tank, and it was just outside of it. Well, this is supporting the corner of the curved roof trusses, so it's a pretty important column. And so we had thought, okay, well, can we somehow install like a transfer girder above the water level, and so that this truss comes down onto that, and then we don't have to worry about it being submerged in water. But the size of a transfer girder that we would need would be so large that it would take away from the exhibit experience. So we decided that it would stay within the exhibit and we would just protect it. So that's this column. Now this one, the concrete one, he's not supporting the roof. His purpose is to support this rebate. The rebate is what holds the acrylic in place. So the original tank had a piece of acrylic right along here, and that's what this concrete column's purpose was. During the Amazon Rising, this little access catwalk was added, and it's also being supported off of that guy. So it's 2 independent columns, but waterproofing riveted steel was going to be very complicated, so we encased it and combined the 2 into 1 column, more or less, and then waterproofed it, and then put a tree around it so you can't see it. And then here are just a couple images of that acrylic being installed. I think this piece was like 32 feet long, maybe. So they're getting it into place over there, and then there it is installed. I think this is an actual photo. This might be a rendering, I'm not sure. It's hard to tell. And then comparison of the rendering to the completed construction. So, as I've mentioned, there's a lot that I didn't get to. Klein and Hoffman were also involved with a capital project that's going on right now too, to replace all those original skylights over the exhibits. We're also doing a re-roofing project over the entire historic building. That construction is happening simultaneously, but is separate from this experience evolution project. Honestly, I could talk for 2 or 3 more hours about this project. The nuances of the design, the things we had to work through when they actually started constructing things. Normally when you have a client, it's people, right? Well, here at the shed, your client is sometimes people, but it's also animals. And so a lot of our initial design meetings and planning meetings, during SD and DD and CDs was with Shed's animal care team. And they would tell us what they needed to care for the animals, how much space that they needed to do their dives into the exhibits to care for the animals and things like that. So truly eye-opening experience to be involved in those major logistical types of projects. But anyway, personally, I think For me, this project is a once-in-a-career type of project, and it's been very professionally fulfilling to see the vision on paper actually come to life. And I'm really excited. As I mentioned, we're currently in phase 3. We're doing foundation work right now and demolition, and I'm really excited to be able to share more on phase 3 when that opens up to the public. So I apologize for going long, but I'm happy to take any questions if anyone has any. Thank you.
Thank you so very much, Michelle. Appreciate it. Wonderful presentation on a very, very challenging project. So we do have time for a couple of questions. The catch is I need to bring the microphone to you because the program is being recorded. So even if you speak loud enough that we can hear you, your voice may not be recorded. Any questions? Yes, just a moment.
Have you worked on any other projects like this that we would know around Chicago specifically?
Personally, no. But some of my colleagues have worked at like the Lincoln Park Zoo and Brookfield Zoo. But before this project at SHED, I have worked on other projects at the aquarium.
Do you have information on any of those projects that you worked on?
Not to this level of detail.
Oh,
but
okay.
I mean, so in one of the East Galleries, which is phase 4 of this project, the reason East Galleries aren't getting as much of a redo, I guess, is because over the years they've kind of periodically done them. And so one of the tanks, I was involved in redoing that 7 years ago, maybe. I don't remember what the exhibit is called, though. I know where it's located, though. We've done a lot of back-of-house stuff, so behind the scenes, places the public can't see, is where a lot of our work is done. Honestly, concrete repair. It's not very glamorous to talk about, but very important, especially for a building like SHED, where water will make your concrete deteriorate, and so when that happens, we need to address it, fix it, and make sure it doesn't happen again. We've done some work in, not me personally, but my colleague has done some work in the Oceanarium, the Granger Pool, which I think is where the sea lion is. She designed basically the enclosure wall and had to figure out what because ASCE 7 doesn't have what the live load is of a sea lion like ramming into a wall, so she had to figure that out. So a lot of interesting things that you just don't think about when you're just thinking about designing a normal building that you have to consider when you're dealing with animals.
Thank you.
You're welcome.
Any other questions? Last chance. All right, let's thank Michelle one more time. Appreciate it very much. And thank you all very much for joining us this evening, and enjoy the rest of the evening. Bye.